has learned the lesson. As walls of oppression come tumbling down and threats appear to diminish in one location, other threats can emerge quickly in another location. To deal with these perils, support from space systems becomes more important than ever. Navy minesweepers with precise positioning never before possible clear the gulf of enemy mines that menace our ships and ships of our allies. Our field commanders in Operation Just Cause and the new Panamanian leaders hold secure conversations directly with the White House. General Carl Steiner, Just Cause commander, proclaims, "I can't go to war without space systems," and he doesn't have to. Without access to indigenous weather data from Iraq and Kuwait, our Desert Storm forces rely exclusively on weather data from satellites to help put our bombs on target. Every day, Air Force, Navy, Army, and Marine forces use the data and capabilities of our weather, navigation, and communications satellites as an integral part of Desert Storm operations. At Space Systems Division, SSD, our mission is to make achievements like these possible with creative, responsive, affordable space systems which give instant support to our warfighting forces wherever and whenever they go to deter war and, if necessary, to fight and to win. We develop critical space technologies, develop space systems incorporating those technologies, acquire the space systems, help launch them, check them out on orbit. Then, when those space systems and the facilities supporting them become mature, we turn over operation to the Air Force Space Command and other operational commands. Today, fulfilling our role in national defense with fewer resources means redefining the way we do business. It means adopting a management philosophy of total quality in everything we do. It means streamlining the process of acquiring space systems. For example, the acquisition of major spacecraft and launch vehicles is now overseen by the Program Executive Officer, PEO, for space, with system program offices for each major program, staffed, trained, and supported by SSD. This integrated team approach extends across SSD, from conducting research and development for new space systems to fielding follow-on systems for mature operational programs. Right from the beginning of a program, SSD builds a close partnership with our customers and users, the operational commands, and our contractors. We save money and time downstream by mutually developing and agreeing to program requirements up front. Even before we develop a request for proposal, when we plan the acquisition strategy, we use integrated product development teams to ensure everything that will happen to a product during development and production is taken into consideration at the beginning. This approach helps us anticipate problems and prevent them, to improve quality, avoid waste, and cut costs as we meet the needs of our operational forces today and tomorrow. Battlefield forces need secure strategic and tactical command, control, and communications capabilities. Long-range transmissions connecting command authorities and field commanders anywhere in the world. Transmissions that interconnect all services using fixed or mobile receiving stations. The spacecraft we developed for the Defense Satellite Communications System, DSCUS, meets that need. Up to 80% of all communications in and out of Operation Desert Storm were made possible by DSCUS. And DSCUS provides the only DoD means for communicating wideband data, which accommodates photos and graphics, as well as voice and data transmissions. To replenish the system, we're preparing to send up more DSCUS 3 spacecraft, which are being prepared to launch on Atlas II boosters. To meet military command, control, and communications needs of all U.S. forces well into the next century, we are building and preparing to launch MILSTAR, an electronic switchboard in space, highly advanced, one of the most technically challenging spacecraft ever developed. In the faceless desert, there are no landmarks to guide aircraft, tanks, infantry. The enemy was at home here. Our troops were not. On the scene in Operation Desert Storm, as it is around the globe, was our Navstar Global Positioning System, GPS, a constellation of what ultimately will be 24 operational satellites, providing 24-hour navigation, positioning, and targeting information in all weather accurate to within 50 feet to any user anywhere on Earth. This capability serves the needs of not only our DoD forces, but also the Coast Guard and civilian users from shippers to surveyors. In the future, the Navstar GPS system will even be available to people in their cars. In 1989, our forces at Pope Air Force Base were alerted to prepare for icing conditions at takeoff for Panama by forecasts from Air Force Global Weather Central, using data from sources including our Defense Meteorological Satellite Program, DMSP spacecraft. That weather data helped the troops make their night drop into Panama on schedule, meeting the critical timing requirements of Operation Just Cause. Refueling procedures in support of Operation Desert Storm were safe and successful because satellite data was used to predict the onset of rain, wind, and cloud conditions. The real-time meteorologic and oceanographic information being provided by DMSP to our forces in fixed and transportable weather stations worldwide is being constantly improved as we put updated operational spacecraft on orbit. This high-quality data from the newest DMSP spacecraft, with its added microwave capability, is more accurate in assessing the location and intensity of storms than previously available visible and infrared data alone. We're working now on highly mobile ground terminals and improved spacecraft that will provide our forces with even better weather data in real time anywhere they deploy. As the world faces the potential for diverse threats from any sector of the globe, our country depends as never before on eyes in space for worldwide surveillance and early warning of enemy threats. A new generation of Defense Support Program, DSP satellites, will provide early warning of a ballistic missile attack from any quarter. To replace DSP at the turn of the century, we are developing the follow-on early warning system, which would detect enemy missiles as soon as they're fired and track them during their powered flight. In related work, we're also managing programs for DoD's Strategic Defense Initiative Organization, SDIO, that would provide a defensive shield against limited ballistic missile attacks, whatever their source.
Let us pursue an SDI program that can deal with any future threat to the United States, to our forces overseas, and to our friends and allies.
We're developing Brilliant Eyes concepts to detect missiles after their boost phase and during their mid-course flight, and then direct our interceptors to destroy those targets. Those concepts employ a constellation of highly distributed, lightweight, autonomous satellites with multiple sensors. The small field of view sensors will focus on specific areas in space, just the ones of interest, which multiplies the effectiveness of the overall constellation. To intercept enemy missiles, we're developing and testing two types of technologies. In the propulsion directorate of our Phillips laboratory, we have successfully demonstrated that a small, lightweight kinetic energy vehicle, which could be based in space, can maintain stability and track a target accurately while its engines are firing and while it's maneuvering. Technologies being developed for this program include infrared seeker technology, fiber optic inertial measurement units for guidance, propulsion and attitude control, and computer miniaturization. Technologies that are applicable to Brilliant Pebbles space-based interceptors as well as other types of spacecraft. We are also applying space technology to the development of directed energy weapons. An orbiting laser would generate a beam that is focused directly on targets. A laser generated from the ground would reflect off orbiting mirror satellites to destroy missiles in flight. In the Relay Mirror experiment, conducted and managed by the Lasers and Imaging Directorate of our Phillips Laboratory on the island of Maui, we demonstrated that existing laser technology can be applied in space. In a series of successful tests, a laser beam hit a target after being bounced off a mirror in space. We need to ensure that any space-based system could survive the effects of harmful radiation from auroras or from a nuclear blast. The Geophysics Directorate of our Phillips Laboratory has conducted experiments to determine the effects of such radiation on the sensors to be used in surveillance space systems. To meet yet another need in our nation's space surveillance effort, SSD built the Space Surveillance Radar System on the island of Saipan, which upgrades our surveillance coverage in the Pacific for tracking low-altitude satellites and detecting Soviet and Chinese space launches. As we face an increasing need for deployment from the United States rather than from overseas bases, our forces, reduced in number, need reliable support and faster response from space systems. One option is the possible deployment of dedicated satellites to meet the specific needs of a theater commander. These tactical satellites would supplement our existing space assets. With its common satellite bus, a tactical satellite could be used with interchangeable payloads, weather sensors, navigation aids, or communications packages. This is just one of the concepts we're exploring as part of our continuing effort to look at not only new technology, but new ways to apply existing technology as we plan for the future. To meet the various needs of our operational customers, we're assuring that our nation will have continued access to space with a balanced, diversified fleet of launch vehicles. For large payloads, we've developed Titan IV, the largest and most powerful of the Titan family of boosters. Titan IV is the backbone of DoD's launch capability for Milstar and other heavy spacecraft through the end of this century. Medium payload Delta II boosters are being used primarily to orbit Navstar GPS satellites. Designed for launching small to medium-sized payloads, refurbished Titan II boosters will be used with future DMSP and National Oceanic and Atmospheric Administration, NOAA, weather satellites. Atlas II will be used with Discus III and other medium-sized satellites going into geostationary orbits. To meet the need for boosting small payloads into orbit, SSD assisted in the design, testing, and evaluation of Pegasus, the first space booster to be launched off the wing of a B-52 in flight. Pegasus was developed by the Defense Advanced Research Projects Agency, DARPA, for both DoD and commercial applications. The Space Shuttle will also be used as a launch vehicle for certain DoD missions, specifically those requiring human involvement in space. The highly accurate solid fuel inertial upper stage, IUS, has been used successfully with both expendable launch vehicles and the Space Shuttle to deliver satellite payloads from low Earth orbits to high Earth orbits. In addition to its use for DoD missions, IUS is vital to NASA for scientific interplanetary missions, like Galileo, a mission to Jupiter, Magellan, to explore Venus, and Ulysses, to probe the Sun. DoD launches are conducted at Vandenberg Air Force Base, California, and Cape Canaveral Air Force Station, Florida. These sites are now controlled by Air Force Space Command to launch both operational and research and development satellites. To support future military needs for more operational and cost-effective launch vehicles, and the future needs of NASA and our Space Exploration Initiative involving the space station, a return to the moon, and placing a man on Mars, SSD is committed to working jointly with NASA in the development of a national launch system. This program is developing a family of new boosters, a new upper stage, and a cargo transfer vehicle to be based on advanced technologies being demonstrated today in propulsion, fabrication, operations such as recovery of the propulsion avionics module, information processing, and new support systems. This new national launch system would form a more reliable, lower-cost alternative to current launch systems and would allow us to respond more routinely to mission requirements. Launches would no longer be treated as special events with long times on the pad. Integration of the booster components and payloads, transfer of the complete vehicle, and launch would all be accomplished right at the launch site. Space Systems would come out of the processing facility virtually ready to fly. And only a small crew would be needed for rapid checkout and launch. The Propulsion Directorate of our Phillips Laboratory is working toward high payoff technologies even further in the future from high energy density matter, which can be formed by depositing energy from laser radiation. This technology could lead to launch vehicles capable of boosting spacecraft into orbit with only a single stage. Meeting the needs of our warfighting forces also involves the on-orbit checkout and control of the satellites, sending commands and receiving data on the spacecraft's health and status. The Consolidated Space Test Center, CSTIC, has responsibility for on-orbit control of R&D spacecraft and provides backup for control of operational spacecraft that are normally controlled by Air Force Space Command at the Consolidated Space Operations Center, CSOC. CSTIC and CSOC are major components of the Air Force Satellite Control Network, which is made up of operating centers and remote tracking stations around the globe. Our System Program Office for Satellite Control and Data Handling serves as the network integrator and sustaining engineer for the common user elements of the network. The office is responsible for modification, improvement, and modernization of all these elements. In addition, we are automating the network's remote tracking stations, 16 antennas at 9 different locations worldwide, for increased accuracy, higher reliability, and lower cost. In an era that promises reductions in strategic weaponry to promote a more stable world environment, our country is more dependent than ever on research and development to keep our strategic forces modern and to maintain their effectiveness. To meet this need, our headquarters ballistic missile organization, BMO, the newest member of the SSD family, is performing R&D on various missile programs, including Peacekeeper ICBMs and existing Minuteman silos, missiles that have achieved accuracy and reliability beyond expectations. The Peacekeeper Rail Garrison, a cost-effective, highly survivable mobile deterrent. The small ICBM, a single warhead system which can be deployed in existing silos or on hard mobile launchers. Advanced Strategic Missile Systems, the only Air Force program dedicated to ICBM technology and advanced development. Rapid Execution and Combat Targeting, a program to improve and support our existing strategic missile force. BMO also provides staffing, support, and training for ballistic missile programs assigned to the Program Executive Officer for Strategic Systems. The key ingredient in our ability to meet the needs of our users is our people. We give them the opportunity and encouragement to stretch their thinking, to exercise initiative, to work as individuals and as teams to continuously improve the way we do business. To support and nurture that vital role, we provide high-quality facilities and services to meet the everyday needs of our people and their families. At Los Angeles Air Force Base, and in San Pedro at the jewel of Space Systems Division, Fort MacArthur. Our commitment to our people is returned many-fold by their commitment to SSD's objective, achieving the level of productivity, competence, resourcefulness, and morale we need to get the job done today and tomorrow. To translate technology into global support from space for our